Today I am going to explain wind tunnel testing. It is included in Unit 2 of Subject Vehicle Body Engineering, 5th semester Automobile Engineering. Table of content. First one, concept. Second, types of wind tunnels. I will explain concept first. It works on Bernoulli's principle. Wind tunnels are used to simulate or study airflow in laboratories under controlled conditions. These find vast application in automobile and aircraft industry, even trains also, to test phototopy for aerodynamic conditions, especially drag force on the phototopy. When tunnels are designed for specific purpose, how internal design for school, lab and university colleges generally between 2 meter to 12 meter long. The wind tunnels in automobile industry are large enough to accommodate whole car in its test center or section. A wind tunnel is specially designed and protected space into which air is drawn or blown by mechanical sources in order to achieve a specified speed and predetermined flow pattern as a given instant or time. The flow so achieved can be observed from outside the wind tunnel through transparent windows attached to the testing section. The enclosed test section and flow characteristics are measurable using specialized instruments. Objects such as model or vehicle can be immersed into the established flow. The objectives of the immersion include being able to simulate or study visualization, observe and measure the flow around the immersed object. Totally, this equipment is used for R&D department to improve the vehicles day by day and achieve fuel economy. Next, types of wind tunnels. Types of wind tunnels are classified on the basis of flow speed, in that subsonic or low speed wind tunnels. Number 2, transonic wind tunnels. Number 3, supersonic wind tunnels. Number 4, hypersonic wind tunnels. Next, based on shape or circuit. Number 1, open circuit wind tunnel. Number 2, suck down tunnel. Number 3, blower wind tunnel. Number 4, closed circuit wind tunnel. Explanation about the wind tunnels. Number 1, subsonic or low speed wind tunnels. Major parts are as shown in the figure. Is high pressure air enters about 15.5 megapascal. It is very high pressure, and control valve is there to control the air, and next perforated plate is there, means having holes. Next, major protective wall, pressure relief wall is there. It will protect the equipment when pressure is high, then specified it opens and it will avoid the damage to the instrument or equipment. Next, subsonic nozzle is there test portion is there, traveling wall probe is there, again choke vanes are there, exit is there, test section is there, separated planes are there, and screen means filters are there. About 8 screens are there. Its working I'll explain here. Maximum flow speed in this type of wind tunnels can be supplied to the instrument is 135 meters per second. It is less than the sound speed. That's why it will be called as subsonic wind tunnels. Flow speed in wind tunnels is generally preferred in terms of Mach number, which comes out to be around 0.4 for this case. This type of wind tunnels are most cost effective, means less cost due to simplicity of design and material. Next, generally low speed wind tunnels are found in schools, colleges, universities because of low budget, low cost. Next, number 2, transonic wind tunnels. The main parts here also, it is closed type. Driver motor is there. Next, air compressor is there. Cooler is there, means after compressing the air, it will heat. Again, it will be cooled by a cooler. Setting chamber is there. Nozzle is there to get the speed of the air. Here, nozzle will be restricted area is there. If restricted area is there, speed of air will be increasing. And after that, the test section is there. It will be straight portion is there. Here, turbulent air will be become streamlined flow on the test section. Again, diffuser is there. Here it is less like an outlet. Outlet again is connected to the inlet of the compressor. Just explanation again. Maximum velocity in test section of transonic wind tunnel can reach to speed of sound just equal to the speed of sound, 340 meters per second. These wind tunnels are very common in aircraft industry as most aircraft operate around this speed. Supersonic wind tunnels. It will name indicates that the speed of the air is very high than the sound. That's why it will be called as supersonic wind tunnel. Here main parts, high pressure tank is there, big tank. The pressurized air will be stored in this tank, means when required you can use this, just like water tank. Here again main parts will be pressure control is there, setting chamber is there, supersonic nozzle is there, sonic throat is there. Throat means just like a venturi, and filtering screen is there, spreader is there, and again straight test section is there. You can keep the model, that also shown in the figure. Next, exit throat is there. Again it is restricted area. Again divergent portion is there, exit. These are the main parts. Here the high pressure air from tank to the up to exit it will be supplying. Again it will go to the atmosphere only. Velocity of air in test section of such a wind tunnels can be up to 1715 meters per second. This is accomplished using convergent and divergent nozzles. Power requirement for such a wind tunnels are very high. Next one, testing wind tunnel, hypersonic wind tunnels. The name indicates that the speed is very high than the sound. That's why it will be called as hypersonic wind tunnel. Here main parts are as shown in the figure. Fast acting valve is there, again nozzle is there, test section is there, diffuser is there, supersonic ejector is there, model ejection system is there, heater air supply is there, and air enters here also through nozzle, again to the test section, again to the diffuser and eject portion. Here wind velocity in test section of such type of wind tunnels can be measured between Mach number 5 to Mach number 15. If it is in kilometers, 18,522 kilometers per hour. This is also achieved using convergent and divergent nozzles. Convergent nozzles are increasing the speed of the air. Divergent nozzles are decreasing the speed of the air. Next type, open circuit wind tunnels. Very clear in the figure, both the openings means inlet as well as outlet are to the atmosphere only. No circulation of the air again here. Controlled air stream as shown in the arrow mark is supplying to the convergent portion to the test chamber. After that it will be going to the outlet through the motor. At the middle only test instrumentation you can keep. This type of wind tunnel is open at both ends. The chances of dirt particles entering with the air is more honeycombs. Means filters are required to clean the air. Open type wind tunnels can further be divided into categories like A, suck down wind tunnel with the inlet open to the atmosphere, and axle fan or centrifugal blower is installed after test section, means at outlet side. This type of wind tunnels are not preferred because incoming air enters with significant swirl, means turning action. Next type B, blower tunnel. A blower is installed at the inlet side of wind tunnel which throws the air into wind tunnel. It sucks the air from atmosphere and throws into tunnel. Swirl is the problem here in this case as well, but blower tunnels are much less sensitive to it. Again, one more very important type, closed circuit wind tunnel. As shown in figure clearly, the inlet and outlet are again connected. The main parts here, guide vanes means to give the direction for the airflow. Model supporting frame is there. nozzle is there to increase the speed. Again, actuator fan is there to suck the air, and again it is applying to the inlet. Return duct means passage to connect outlet and inlet of the system. Outlet of such a wind tunnel is connected to inlet so the same air circulates in the system. The chances of dirt entering the systems are also very low because it is not open to the air. Closed wind tunnels have more uniform flow than open type. No variation in the flow. This is usually a choice for large wind tunnels as these are more costlier than open type wind tunnels. For your study purpose, I will give some multi-choice questions. In that, number 1 question, wind tunnel works on dash principle. Means on which principle it will be working. The choices are Bernoulli's, number B, Ohm's, number C, Newton, number D, Pinch. Correct answer will be for this question Bernoulli's. Next, question number 2. If the maximum speed achieved by the wind tunnel is less than the speed of sound, it is called dash wind tunnel. The correct answer for this question, subsonic wind tunnel. And question number 3. A wind tunnel designed for school lab is 2 meter to dash meter long. The choice answers are number A 8 meter, number B 6 meter, number C 12 meter, number D 10 meter. The correct answer is 12 meters. Next, question number 3. Question number 4 it is, sorry. Dash is installed at the inlet of wind tunnel. The correct answers or choice answers are motor, screen, blower, cam. The correct answer for this question is blower. And last question or 5th question is closed wind tunnels have more dash flow than open type. The multi-choice answers are uniform, B air, C speed, D low. The correct answer for this question is uniform flow. Thank you.